Hello everybody. Today we're going to talk about end behavior in polynomials. So a polynomial is are functions that have the form y equals ax to the power of n. And the reason that there is an n right there is because this can be any power. Any positive power. Okay, and you can have multiple terms like the examples that you see here, so here 3 terms, right? Here you have 3 terms, here you only have 2 terms, and last class we talked about power functions, and those are just single term polynomials. Okay. The graphical end behavior. So basically what we're looking at is as the function progresses to the right or to the left, we are looking at whether it goes up forever or down forever. The turning points and zeros are rich and interesting, and we're going to explore those in future lessons. But today we're going to only look at end behavior, which is the directionality that the graph goes on the far right or far left. So when we talk about this definition that's down here, the end behavior of a function is how it acts graphically as x gets very large, which is the positive is going to go on the right-hand side of the graph. The negative is on the left-hand side of the graph, right? So symbolically, it is how f of x, or the graph, behaves as x goes to infinity, which would be to the right, or x goes to negative infinity, which is on the left of the graph. All right, so exercise 1. Given this function, y equals -1/2 x squared plus 3x plus 4, you are meant to sketch a graph below for the indicated window. Now, I don't have a graphing calculator to pull up here, so I graphed it on Desmos. You can see the negative right here, which makes it concave down. And then some other things that we can see about the graph. This plus 4 right here is my y-intercept right there. And now we're going to look at how do we analyze the end behavior of this graph. So on this graph, we can describe the end behavior of the function as x goes to the positive infinity. So this is as it's going to the right. So on the right-hand side of the graph, it's going down forever. So f of x is going to negative infinity, would be the answer for that. And then separately, we can look at as x goes to, on the left-hand side of the graph, as x goes to negative infinity, that's this one on the left-hand side. And that is also going down forever. So f of x is going to negative infinity. So I often will go towards negative infinity here. And then here I would go towards negative infinity here. So the end behavior of all quadratic functions, and you guys should know what a quadratic function is, but quadratic functions are a power function, a polynomial, with a power of 2, right? And x squared as its highest power term. And that's to either point upwards, and the upward is if we have a positive a, so it's concave up, or we can have a pointing downwards, what's going to negative infinity, which is a negative a or concave down. All right, so here we have 2 cubic polynomials. So a cubic is going to be an x to the 3rd power. And so we can see this x to the 3rd power here. We can see this x to the 3rd power here. Now, we have them pointing in different directions. So let's first compare them to quadratics. So remember, quadratics go like this, or they go like this. So the end behavior goes in the same direction. So if it's a positive a value, they're going to positive infinity on both sides. If it's a negative a value, it's going to negative infinity on both sides. So in this case, what we're looking at though, is we have end behavior going down and up, or up here and down here. So the end behavior goes in opposite directions. Okay, so that's how we can tell a cubic from a quadratic. So y is the end behavior of f of x, which is this one, the opposite of g of x, which is this one. So y is this one going down on the left-hand side, up on the right, versus this one's going up on the left and down on the right. So the reason for that is that g of x has a negative leading coefficient, which is just the number on the highest power. Term. So we have a -2 right here, which made the graph had a vertical reflection. Sort of like our negative a value that we had here in blue, pointed downwards, that was a vertical reflection. All right, so now we're going to look at a quartic function. So a quartic function is a degree for polynomials. So that means that the highest power is an x to the fourth. So this is a really long string. You won't always have an x to the fourth, x to the third, x squared, x, and the 240, which is a constant. You won't always have all 5 of those terms, but in this case we do. So the end behavior of this one, as x goes to positive infinity, which is on the right-hand side of the graph, we see that it's going to positive infinity. It's going up forever. So we say f of x is going to positive infinity. So as x goes to negative infinity, which is going to the left on the left-hand side of the graph, that's this one, is also going up forever to positive infinity. So f of x is going to positive infinity. So does the end behavior of the quartic function resemble that of a quadratic function or a cubic function? So this is sort of like a multiple choice question here, and we are looking at different color. So is it more like a quadratic or more like a cubic? Well, remember my quadratic went like this or like this, right? So it had the end behavior going up on both sides or down on both sides. Our cubic functions went more like this or like this, depending on the leading coefficient. So because of the fact that it went, it's more like this one, because the end behavior is the same on both sides. All right, using the axes and window indicated above, sketch the function of g of x is equal to negative x to the fourth minus 4x cubed plus 23x squared plus 54x plus 125. Why do the ends of this quartic function point in the opposite direction of those of f of x? So if you remember on the previous slide, f of x was the one that went like this, okay, where it was going up. So this was going to positive infinity, remember, and this was going to positive infinity. And now down here, we have it going to negative infinity on this side, and this one is going forever to negative infinity. Okay, so why is it going in the opposite direction? Well, this has everything to do with that leading coefficient that's being negative. So the negative leading coefficient caused a vertical reflection. Sorry if that green was difficult to see with that background. All right, so as should be evident from the polynomial examples we've seen, the end behavior of a polynomial is determined by two factors. So here's the important things that we need to pay attention to here. So the degree of the polynomial is going to tell me about whether my end behavior is the same on both sides, or whether it is going to be one going up and one going down on either of the sides. And then the leading coefficient of the polynomial is what tells me whether there was a vertical reflection or not. And important to note is that the degree of the polynomial is the highest power. Okay, so fill in the following statements to make them true. When the degree of the polynomial is even, so my degree of the polynomial is even, like an x squared, an x to the fourth, an x to the sixth, etc. The ends of the polynomial point in the same direction. And we have like this, or we had this, right? So the end behavior is pointing in the same direction. When the degree of the polynomial is odd, so that was like my x cubed, which is going to be similar to my x to the fifth, etc. The ends of the polynomial point in the opposite direction. And I had some examples where my x to the cubed, like this, okay? Or the one that had a vertical reflection like this. So when the leading coefficient So the leading coefficient, which is on that a x to the n, so that leading coefficient, changes sign to negative. The ends of the polynomial change direction. So my vertical reflection would go like this, or my cubic would flip to look like this. Okay. All right, for each polynomial graph, state whether the degree is even or odd and whether the leading coefficient is positive or negative. So on this one, because they're going in the same direction, both going down, my degree is going to be even, because they're going the same direction. And my leading coefficient must be negative, because my end behavior points down. All right, so this one, they're pointing in opposite directions. So my degree must be odd because it's going in opposite directions. And my leading coefficient must be positive. And really, you can see exercise number 3 for more information, but basically my positive is the one that's going to start at the bottom left and go up like this. My negative, when I have an odd degree, is going to start at the top left and go down. So think of it like an increase is positive and a decrease is negative. Well, that's all. Have a good day.